In this lesson, we will be graphing inequalities. At the end of the lesson, you should be able to discuss the relationship between the inequality symbol and the boundary line, and graph an inequality written in different forms with two variables on a coordinate plane. So the difference between a linear equation and a linear inequality, both graphs are straight line on the coordinate plane. An equation means all points on the line are a solution, and an inequality means all points above or below the line are solutions, and it may or may not include the points on the line. So in this one, we have a linear equation. That means all the points on the line are included. So this means I'm going to plug in -2 for x. So greater than 2 times -2 minus 1. -2 times +2 is -4, minus 1 is -5. Then I plug in -1, and I get -3. I plug in 0, get -1. Plug in 1 for x, get 1 for y. Plug in 2 for x, and get 3 for y. Now I'm going to graph those points: -2, -5, -1, -3, 0, -1, 1, 1, and 2, 3. Then I look over here. I see that my boundary line is dashed, so I make a dashed line. I'm going to use a test point of 0, 0. 0 is greater than 2 times 0 minus 1. So 0 is greater than -1. So yes, that means this is a point that works in my inequality, which means everything on that side is a yes. So now we can graph it using slope-intercept form. So I'm going to need to get this into slope-intercept form. So the first thing I'm going to do is distribute. 3x plus 6y is greater than -18. Subtract 3x from both sides. Get 6y is greater than -3x minus 18. Divide everything by 6. And we get y is greater than -1/2 x minus 3. So I'm going to graph it. I begin at -3, and then I can go down 1, right 2, or I can go up 1, left 2. So down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2. My line is dashed, and then I'm going to plug in 0, 0. So 3 times 0 plus 6 times 0 is greater than -18. So 0 is greater than -18. So that's yes. So I'll shade above. A delivery truck is transporting televisions and microwaves to an appliance store. The weight limit for the truck is 4,000 pounds. Televisions weigh 77 and the microwaves weigh 55. Write an inequality. So I have the televisions weigh 77. And when I add that to the 55 pounds per microwave, it has to be less than or equal to 4,000. So it says, will it be able to deliver 35 televisions and 25 microwaves? So I'll plug in 35 for the televisions and 25 for the microwaves, and make sure that it's less than or equal to 4,000. So 77 times 35 is 2,695. And 55 times 25 is 1,375. We need to make sure that's less than or equal to 4,000. When I add those together, it's 4,070. So the answer would be no. Each child at the birthday party was given $5 to spend at the arcade and games and rides. Each game cost 25 cents and each ride cost 50. What is the maximum number of games or rides each child can play? So my equation is going to be 25 cents for each game, plus 50 cents for each ride, and they cannot spend more than $5. So what I would do is say, okay, well, if my maximums are, if we have 0 games or 0 rides. So if I plug in 0 for games, 0.25 times 0 plus 0.5r is less than or equal to 5. So I'll divide both sides by 0.5 and get r is less than or equal to 10. So if they don't play any games, they can ride 10 rides. Do the same thing with 0 for the rides. So 0.25 games plus 0.5 times 0 for the rides is less than or equal to 5. So I got 0.25 games is less than or equal to 5. Divide both sides by 0.25. And our games is less than or equal to 20. So they can either play 20 games and no rides, or 20 rides, no games. All right, match each inequality. So number 1 goes with C. Number 2 goes with A. 3 is D. And 4 is B. Which ordered pair is easiest to use for testing when which region should be shaded? The easiest point is 0, 0. You cannot use 0, 0 if your line goes through 0, 0. And what's the name of the line that divides the regions? The boundary line.